how many of you have totally and absolutely broken production on something you thought was very simple and should not have behaved the way it did? Anybody? Yeah, there you go. Great. So I expect no judgment for anybody that had a hand up. I was also kind of hoping to be towards the end. It's comic relief, really. But it seemed a little unfortunate to go after the keynote. But as he was talking about building systems, my talk is very much about cowboying code and the results and effects of it. So I think it's pretty fitting. Like you said, my name's John Carstens. I really love working at Elixir. I've been doing it for a little over 3 years. And then outside of that, I spend my time woodworking, and lately really gotten into automating my house with nerves, to the point of an obsession, really. So look out in the future, you might see a talk about that. Wink, wink. Here's my Twitter and GitHub if you're curious. Spoiler alert, my Twitter is not that exciting, but it is getting better. In fact, I tried to blast out and see if anybody wanted to make a tweet snippet in ways they broke production and put it in this talk, but I got 0 responses, so joke's on you guys. Didn't want you in my talk anyway. I'm a senior engineer at a fintech company called MX. We contract with banks and credit unions to supply and integrate clean, accurate financial data for the end user. We're all about advocating for the end user and helping empower everyone to be in control of their own finances. It's primarily a Ruby shop, especially JRuby, and with some Elixir and Go backend, React front-end, and a lot of C++ for our mobile. So to get into this, it was really a coworker of mine, Michael Reese, if anybody is familiar, that was really determined that Elixir could solve problems at MX, and then he eventually coaxed me into it as well. So all of these examples from this talk that I'll present are actual production issues we've run into as he and I and a few others pioneered the first production Elixir's apps at MX. So yeah, also as a side note, we also do a remote nerves meetup once a month if anybody's interested in that. So let's go case 1. So the code that I'll present, our code is mostly proprietary, so the code that I present are going to be really simple, contrived examples, like this one. It's very simplistic, but we deal with transactional data because it's mostly financial data. And in one case, at the core, what we really wanted to do is just accumulate. We wanted to collect these transactions based on an amount. And if you look at this, we essentially just said if the amount is greater than 0, then we want it. Add it in, grab it, do whatever we want with it, and if it's not, then ignore it. Super simple, right? Like, this is covered. Great. Ship it. Oh, dang it. Thousands of lines, thousands of errors. It was deployed. We made it. Also, caveat, we were literally learning Elixir and also learning how to run production, so keep in mind. So what's going on? The error was 10 plus nil, which is right here. But, that doesn't make sense because we have this awesome guard clause. Amount greater than 0, how does it get past that? So I went to my handy-dandy Hayek session, typed it in, see what happens, and what? Oh, man. Hold on. I cannot handle this right now. So I started testing everything I could think of. And literally all of these are greater than 0. True. It comes out. Fantastic. There are lots of things greater than 0. Well, that's, just coming to Elixir is a little odd. So I start digging in the code. Why is this true? And I go to the kernel module, because Elixir is also fantastically documented. And I find this comparison, and it says, go to the Erlang. It's making a call to the Erlang module. So I go to the nice, fun Erlang module, go through a few thousand lines searching for this implementation, and found nothing. Eventually found some notes about BIFs. And of course, I had to Google what a BIF was, a built-in function. And so I thought, oh, well, maybe it's a built-in function since I can't find it here. So I found method to check is built in. Sure enough, it is a built-in function. So I go down this rabbit hole of BIF C files. I'm trying to find this built-in function, and I don't know a lot of C. I'm not that super great at it, but I finally tracked it to this point in a utils C file. And I think I can do these conditional statements. So I go through this just manually. It's nil is an atom in Elixir, if you didn't know, but 0 is not, so that one's out. They're not both small, which would compare to small integers or small list values. They're definitely not floats, neither one of them. So obviously, I have to go to this ERTS compare compound. So let's go find it. Oh, there it is. And Keynote has a limit of what I can paste, so this isn't even all of it. So no thanks. I got to this point, and I said, yeah, somebody smarter than me who knows C better can go through and really, really explain why nil is greater than 0 and all this other types. So I'll leave that to those individuals, those smarter. So what's the lesson from this? What are we going to take? Well, with great power comes great responsibility. And I love this. This is fantastic. Elixir is dynamically typed. It's inferred at runtime. And that's great power. You get more concise, less boilerplate code, quicker, easier, generic code. You get lots of benefits. But with those benefits, you need to be very diligent in your types and what you think and do not think should work. So here's a couple things that we kind of thought about we could do. Elixir's great. It has pattern matching. Pattern matching is very fast. And we could write in a case statement to match everything we don't want to check for. And this would work. But, in our case, where we only care about one specific case, writing all the non-cases could get really cumbersome and over-verbose. So Elixir also has guards. We could do much better guards. And in fact, we could do this is number. Let's make sure it's a number first, so we know the type is what we want. Float or integer, don't really care. And let's compare that to 0. And this was the fix. This suffices for our needs. But also, I want to put a plug-in for property-based testing. With a dynamically typed system and a great tool like property-based testing, this would have, in hindsight, been very fantastic. We do have pretty good test coverage, or at least we thought we did. And being able to create a case and condition where we know very explicitly the output of it, and then to just say, throw whatever you want at it. I am very confident this would have caught it before production crash. So yeah, since you're not always prone to writing every pattern to match or superb guards, property-based testing is a very, very good way to go through. So let's go, what am I looking at here? Let's go to the next case, because that was fun. We have what I'll coin as a processing engine to handle various different formats of data. And we want to be able to ingest all those different formats of data and then consolidate, get what we want, and feed it back out in a singular defined format. So we essentially created these reactors. And each reactor would know how to react to a certain set of data. So we wouldn't keep all logic in a single module. We could have very defined specific logics. And we would go through each reactor, iterate through here, and tell it to apply a react function with these arguments, the state, state of the process, and whatever event comes in, and its event data. And that reactor would be in charge of supplying any of these returns. So one could be ignore, and if it's ignore, let's recursively go back, because we pulled the tail and we pulled the candidate to check. Let's recursively go back, send it again, and try the next reactor, and let's just go down the list in a very linear way. It could return some of these items where either we're done, we've got some new state that reactor's modified, and let's do some arbitrary function to finish off and end this process. Maybe it errored, something happened in the reactor that errored, let's handle that. Or, we could get some get some tuple back with a more work atom or some other custom atom that we may define to handle it further or do something somewhere else. So we built a first reactor. This looks great. So let's build the second one really quick. Reactor B, I wanted to handle things differently. And since it was the Wild West, this is essentially two people developing more or less independently with a common idea. So we knew that we should have a react function. It should be an arity of 2, and we want the state to come in, and we want a tuple with an event name atom and some event data. And then we know that that reactor should decide if it can handle this data, and it knows what to do. And should ignore if it doesn't. So if anybody's really good, can tell me where this breaks. 100 points for you. Ship it. What's the worst that can happen? Crud. All right, so we got filled with logs of reactor B stinks. Nothing's matching a react arity2 method. So what's going on? To save you some problem, in this specific case, reactor A has kind of this catch-all. If it doesn't know anything that's coming in, just default to ignoring it. And this was kind of the idea that we wanted to keep. We wanted the processor, if nothing handled it, nothing reacted, we wanted the processor to just be this central source to handle it. So, I mean, that's missing reactor B. What's going on? So let's add it in. That looks good, right? Let's ship it. Oh, crap. Oh, man. All right, well, something else is going on. Let's look at this really deeply. Let's go back to another PR. Oh, I see what's going on. Reactor B, for some reason, put this in a tuple, they thought. But we were expecting just a single atom. So it's not matching. Apparently it handled something, and it's not going on. So yet again, let's rewrite it, and somebody ship that. I should caveat, this is in no way an indication of our peer review process, or not peer, or pull request process. It is actually very good. We're just winging it. Oh, crud, one more time. So what's going on here? Now we have some map, it's got some key, howdy, all right. Well, you had one job to do, reactor B, and you didn't do it. Here's where it's broken. In a valid response that we should handle, we actually did expect a tuple that time, but reactor B just gave it a map. This one actually, I mean, this is like 10 seconds to explain. This was a few hours of digging through logs and trying to figure out, and all these modules trying to figure out what's going on. So let's fix that one more time. Ship it. Everyone cross your fingers. And it works. The world is great. Our reactors are behaving as expected. No errors in logs. So what's the lesson here? We've got these two different reactors. We defined what they should do. We knew how we wanted the processor to handle things. We wanted reactors to be just modular to handle very specific things, but give it back to this processor. We essentially expected them to all have the same behavior. You know, we had this reactor, they should have the should handle, they should return this response that's formatted in a tuple. Like, this is all very standard, every one of them should have. And they ignore, forgot I had that in there. Oh man, and in some cases, we wanted this catch-all to just absolutely, in the last resort, don't even try if you don't pattern match the other arguments. We expected them to have the same behavior. Wait a second. That looks right. America is apparently the only way that spells it the other way, and Elixir expects this. So, from the Elixir docs, behaviors in Elixir and Erlang are a way to separate and abstract the generic part of a component, which becomes the behavior module, from the specific part, which becomes the callback module, and that's exactly what we needed. In fact, you can write a behavior very simply where you can define some types. We define callbacks that are expected. These are essentially functions that we expect to be there with arguments of those types, and we expect the responses of those types. And then a should handle method, but maybe every reactor doesn't want to use that should handle. They want to use some other custom logic to decide. So we'll make that one optional. And what that allows you to do is write things like this. Let's say we're making a new reactor C module, and we require the reactor behavior with our predefined functions and arrays. And in code editors with Dialyzer, you'll see warnings like this immediately. Oh, crud, I haven't implemented this React2 method. And in compilation, you'll see something happen like this. Oh, crud. If you're like me, warnings make you cringe, and you can't do anything until you solve all the warnings, which is very frustrating for external libraries. But at least in my code, I'd go through and, oh, crud, I need to do something there. Or in our CI, it failed. Even further, you can mix compile warnings as errors. You can prevent compilation and just fail right there when you don't have the correct behavior implemented. You can also get really fancy defining a using macro in this reactor module, and you can do some pre-generated code and get crazy with that. I didn't want to show it. It's really overkill for this example, but it's possible. Oh man, is that all I had? That's all I had. So anyway, behaviors are good. Behaviors provide warnings. If you have the same data or the same functions that have to go through, this would be a great way to solve a lot of trouble. And in our case, it would have solved tons of trouble, especially when you have multiple people developing, to know that the requirement is to use our behavior, and that can help guide the developer independently on the predefined specs, and would save lots of time, lots of errors. Oh, there it is again. So anyway, case number 3. In the beginning of an app, a lot is unknown, and I had a few cases in production that were just, like any new Elixir production developer, making me scratch my head. And a lot of this could, again, be poor design. Just remember, brand new to Elixir, especially in production, and really any tooling. And nothing made sense. I could not reproduce, having a heck of a time, so I did what any good developer would do in a case like this, is I puts everything. I'm going to see what the data looks like and send it out, and I'm just going to watch the logs and see what happens. Ship it. Let's do it. Seems like a good idea. What could go wrong? Oh, crud, lots of things. Oh, man. Something's not implemented, dang it. All right, so Elixir has a logger. Now, I need this quick, so I'm just going to go in. Let's put in a logger. Maybe debug does something different. That's what could happen. Ship it. Oh, crud. It's the same thing. All right, so now I'll go back in, and I'll actually look at the documents and see if there's defined ways of what's going on. And it turns out we had some map or something, and it wasn't implemented for. So then I end up finding this inspect, and that's fantastic, because inspect does some more processing to be able to print out lots of different types without breaking. And then you can also find this IO inspect, right? And actually, whatever you put into this, you can give it a label, and it will return back the argument that you gave it. That's super fancy, super nice. Would have been really good to know off the bat, right? So what's the lesson here? In my case, it was to slow down. Things in production get really nasty, right? But instead of just trying to, things were getting difficult, we just went understanding, taking the time to read through documentation for Elixir, one of the best documented languages I've ever used. Look at the forums. It's an active community. Find if there's a way to help through it. And even look at referenced module code. When I finally went back and I looked at string.chars in the chars module, and see, oh, it's implementing it's a protocol, and it's implementing for these types, and if it's failing, then it's a type that I'm not using. So that would have been really good. In fact, if I had spent just a few moments Googling, I would have most definitely run into this, which is an Elixir language web page about debugging. Exactly what I needed. And in fact, I would have even seen you can actually attach a debugger to a live running production process and see the values coming into there. This is taken directly from that page, by the way. This is exactly their example. That would have been great to know. Way more valuable than printing and looking at logs. So there are lots of great articles and great talks about this debugger and debugging practices, so I'm not going to get real into detail. Google has those answers for you. So we'll go to case 4. And this is actually zooming pretty through. Numbers are hard. So in dealing with transactional data from lots of different sources, in our system, we want to deal with transactional data as a predefined format. And that's to say, we want them as floats, and we don't want any negative or signage on it. We just want a positive float, no matter what. We handle determining if it's a credit or debit on our own. And so in some of the transformations, once we're getting that data and we have to transform it, we'd use some helper functions like this, where we would say, make it a non-negative float. And because floats are hard, essentially, make it a string, and then do this crazy regex, let's pull some numbers out of it, let's take out things like commas and all that, and let's make it into a float and send it for our data. And all was fine for a while, everything was great, we didn't have any issues, but then we started getting some bad reports from a customer going, oh, crud, that is quite a difference. Very wrong amount. So I was pulled onto this very quickly, also scratching my head, but luckily we had an exact user, a very recent case, we could pull some of the data and kind of compare it. So I pull out an IEX session, and I start typing in some values. All right, that's exponential notation, that's not too bad. In my method, I two-string it. Oh, crud. That's weird. So let's use oh, crud. Well, that's what's broken, but what if they give me a string that's the correct float? 12 and, oh, man. Well, I see the problem. Yeah, handy dandy IO inspect helps here too. So, oh, no farts. So, what now? Erlang seems to like everything in exponential notation when it's of a certain size, and it's usually when it's 4 digits long at least. And I'm sad to say there that I've failed you guys. I have not found a lot of info on why this design choice. I also haven't found a lot of info if you can toggle it, if you can set a limit for when you want it to print the full number versus exponential notation or scientific notation. So if anybody knows, that would be fantastic knowledge to have. But my assumption is because floating point math in computer science is hard. Computers are bad at floating point math. There's lots of trickery to compare a base 10 system of math like ours with a binary system that's on the computer. So my guess, and this is a total guess, is that dealing with exponential notation and dealing with those floating points in such large values for comparisons and conversions just may be a little easier. Don't quote me, not 100% sure, that's just a guess. And I've got lots of resources if you're really curious on this topic afterwards. So some of the fixes that we went through, so you can use a library like Decimal. And so I took this non-negative float, and instead of just sending everything through two-string and thinking that it's okay, I restrict it with our handy-dandy, awesome typing guard class into just the numbers. And if it's not a number, then go through the string conversion, all that jazz. And if it is, then we go through that decimal, we switch the sign and convert it back to a float, and all is happy with the world. I even added some more guard clauses to this string to float, so that if I, for some reason, call this outside of this scope, and it's actually a float, just give it back. Don't even do anything. If it's an integer, use decimal again. Make things a little simpler. You could also get really crazy, because Elixir is awesome like this and lets you do stuff, and implement toString for float. So this IO data to binary is what it does already. But then you could say, if it contains that exponential, that e, well, let's do some crazy work. Let's go through lots of conversions, take things out, move it around, send it all back to a string representation of that float without the exponential. I decided against this because in our case, we didn't want just to fix the string, or the float to string and back conversion. We wanted the signage to be changed. But also, this is a pretty intense case, and it's possible. I wanted to showcase, is it recommended? I don't know, but it's there and possible. And there might be even other better options, better ways. Another, very simple, is just use Erlang. Erlang has this nice float to binary that, in fact, will take that exponential notation and return back the correct formatted string. Very simply, you can decide decimal points, super simple. We've actually used this in some other cases as well. So, oh yeah. That was a fun movie. Here's my obligatory links for some of the images I used, and that's all I have for you.
Thank you. That was a really good presentation. I have a story about learning by breaking something in production. We had this system where we had to use SOAP to, send stuff back and forth. And part of this SOAP we had to attach PDFs to it in base64. So it was huge XML strings. And at some point, we wanted to we had some issues. So we wanted to try to debug things. So we started doing logger that debug in there. So it worked in production. That's fine because we weren't doing the debug in production. But then we actually wanted to see how things were working in production. So we did logger.info. And apparently, every time that it was hitting that code, it would crash the entire Erlang VM because it was too big. So. By the way, don't do that. All right. Do we have any questions for John? Hold on.
So did y'all wind up, I was looking at something similar to your case 4 recently. Did y'all land on using decimal to handle those types of it looked like you were doing maybe currency handling or something like that, or did you try some other library eventually for dealing with?
No, we've landed mostly on decimals because we have very specific formatting for those currency. A decimal was just fine for what we needed. And we weren't doing much comparison outside of that. But if you're doing a lot of comparisons and conversions from even more widely unknown, then it might be worth researching outside of that.
Okay, thank you.
So this may be more of a suggestion than a question, but have you tried just maybe representing the money as integers in cents? So if you represent it as a number of cents, instead of 1.20, you have 120 cents.
Yeah.
And then you just basically convert it to what you want it to look like on the client side.
Yeah, there was a consideration of that. But so in these particular apps, it was kind of this a side service using with our core platform. And our core platform had already very specific requirements. And in the beginning, it was just about getting up and quick. So some of this has even changed since then. And past that consideration, we just thought maybe it was a little more overkill, a little more work. But really not much past that. It was get it fixed and let's get it back into the system quick.
There's also a more, like, if money doesn't exist as just cents, even though we only, like, transmit it as just cents, which means that if you have anything that's multiplicative, I think I'm loud enough probably, but if you have anything multiplicative or divisive as a part of your process, then you can't store it as integers, and you actually have to do the float math, and then have, like, your cents version of it, keep track of your remainders somewhere else.
Yeah, I mean, those are good suggestions. That's definitely something that we could explore more. Sure.
Any other questions? If not, give it up for John.